Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to kickstart the discussion on digital transceiver. I will explain the broad diagram of digital transceiver, mainly focus on the source encoder, why we need source encoder in the transceiver, why the need of encryption, and then what will be the role of the channel encoder, what is the function of a bandspam filter in a digital transmitter. So basically all this will be the objective of this video. Guys, if you're keen to know more about digital transceiver, please see the playlist under the description. Over there, you will be able to find a series of discussion on digital transceiver. This is my email. If you have any question regards on this discussion, please drop me an email. Okay? Or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, just give me a few seconds. Press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for some support. Some fun fact before we kickstart the discussion. Okay, how does this NIM transceiver actually come upon? Okay, so basically the NIM transceiver actually obtained from transmitter. Okay, so basically the trans is actually from the transmitter and the receiver is actually from the receiver. So basically this is how the name of transceiver actually come from. Basically in short, it's basically from transmitter and receiver. So therefore, a transceiver, basically they can able to work as both a transmitter and also a receiver. Hence, it will be able to transmit and also receive the radio wave using the same antenna. Okay, so basically this is the keyword, using the same antenna. These two related functions are often combined in a single device to reduce manufacturing costs. For example, our mobile phone is actually a transceiver. Our walkie-talkie is also a transceiver. Okay, so basically, this is a so-called a simple explanation on transceiver. Let's quickly understand the block diagram of a digital transceiver. Okay, so the digital transceiver, in short, they actually represent a digitalization front end that take an analog signal. As you can see that basically for digital transceiver, they can also take an analog signal and then they actually digitalize that. Okay, so basically everything from this onward will be all digital signal. Okay, so basically this video, I will mainly focus on these few blocks over here. But over here, you can see that this is actually one device, which is called transceiver. And inside the transceiver, you can see that this is actually the transmitter and this is actually the receiver. Okay, so keep this in mind. The antenna is actually the same antenna. Okay, so basically, although you see two antenna over here, you just imagine there is only one antenna. In short, there is actually a duplexer. The duplexer will switch either to the transmitter antenna or the receiver antenna. Okay, so basically, this is actually the block diagram of digital transceiver. Okay, so let me kickstart. As I mentioned earlier on, this video, I will discuss what is ADC, analog to digital converter, source encoder, encryption, channel encoder, and last but not least, baseband filter. Okay, so basically this will be my discussion. So from here you can see that basically if the signal is an analog form, okay, it can also fit into the digital transceiver. But before it actually can come into the digital transceiver, it actually need to go through the analog to digital converter. So from here, you can see that the signal actually convert from analog form to digital form before it actually fed into the source encoder. For example, over here, imagine if the signal is actually digital, naturally digital, then it will go directly to the source encoder, as you can see from this diagram over here. Okay, so basically depend on your source, whether is it analog, whether is it digital. So basically they will be fed at two different input over here. Okay, so basically you can see that these are all the signal. Okay, so in a nutshell, okay, so what is the role of source encoder? Okay, so for the role of source encoder in a digital transceiver, they simply remove redundancy. Okay, so what they actually remove? Okay, I'll come to this shortly. Okay, from the original data source so as to make it more efficient for transmission. Okay, so basically most of our data, okay, for example, can it be speech, video, text, they actually contain a very significant amount of statistical redundancy. Okay, for example, in text form, okay, so in English language, okay, the letter Q is always followed by a U. For example, quiet. Okay, so basically you can see that this Q is most of the time followed by the Q. So again, we can reduce the redundancy. Okay, for example, once we write Q, we know that it actually will follow by U. Okay, so basically we reduce the redundancy of sending the message U. The letter E is far more common than Z. Okay, so if we send every characters with the same numbers of bits, we will be wasting our capacity. Hence, source encoder scheme like Huffman coding assigns shorter bits sequence to more common symbols and longer sequence to the less common one. Okay, so basically from here you can see that how they actually remove the redundancy from the text. For example, okay, for English, Q normally will follow by U, so we actually eliminated to send the U message. And then on the other way, okay, basically anything that is very common, okay, we can actually use this Huffman coding assign, okay, which actually has a shorter code to send the more common symbol, while we can send the longer sequence to the less common one like Z. Another example will be video. Okay, consecutive frames in a video are actually very similar. Okay, which means that video are actually sent frame by frame. Okay, so the consecutive frames, okay, on every video, they are actually quite similar. So instead of transmitting all the pixel data for every frame, a source encoder, for example, the MPEG standard, they will send a reference frame and then only the difference for subsequent frames. Okay, so basically this is how they actually remove the redundancy. Okay, so basically they only so-called send the different rather than every frame, every pixel. What will be the benefit? Okay, when we actually remove, okay, the redundancy, the source encoder actually reduce the numbers of bits that is actually required to represent the information. Okay, so this simply means that the same amount of information they can be sent faster and also using less bandwidth. So this is the role of source encoder. Next, coming to the role of encryption. Okay, so encryption, okay, in a very simple definition, is simply the process of translating plain text data into something that appeared to be random and meaningless. Okay, for example, let's say this is actually your message. You can see that this is the message at the input of the encryption. So what happened here is basically you can have a very simple form of encryption. For example, this is the even bit, this is the odd bit. I can actually interchange the even bit and the odd bit. Basically, when you actually do this, you actually do a form of encryption because, okay, the original message actually changed completely. Okay, so basically, this is actually the new message. You can see that this is actually the new message that is after the encryption. I do a very simple encryption by exchanging the position of the even bits and the odd bit. And with this, I actually come out another new message which may not be able to understand when people actually read this message. So this is actually the role of the encryption. When they actually receive this sequence of bit, they will be able to decode my message. However, they do not know how actually do on this encryption. By simply interchange the even bit and the odd bit, I actually arrive another message. When they actually receive this message, they will not be able to recover my original message except that when they know that I actually interchange the even and odd bit. So basically the receiver will be able to know the sequence, how to convert this new message back to the original message. However, when this message is actually sent over the air, okay, those who does not have the protocol, they will not be able to understand what message actually I want to send. Okay, so basically this is actually the role of encryption. Next, okay, so we have done the analog to digital signal, we have done the source encoder, we have done the encryption. Next will be the channel encoder. Okay, so before I come into the discussion of channel encoder, if you have learned something from this video, seek your help by like this video. Guys, if more of you guys actually help me to like this video will have a better chances to reach out to a larger audience. So guys, help me press the like button now. If you have learned something from this video, urge you to support me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly understand the role of channel encoder. Okay, so this is actually the input, this is actually the output of the so-called message. Okay, so what is the purpose of channel encoder? The key purpose of the channel encoder is to introduce some redundancy in the binary information sequence. Mainly, okay, it is used to at the receiver end to overcome any effect of noise and interference encountered in the transmission of the signal through the channel. When we actually send a signal, okay, so there will be a very strong chance that some of the bits will be corrupted, okay, corrupted by noise. So therefore, we have this channel encoder. What they actually do is they add a extra bit, for example, and with the help of the extra bit, we are able to know that whether the message has been corrupted by the noise. Let me give you an example. For example, this is a message that is at the input of the channel encoder. So now what happened here is basically I add in one addition bit. Okay, so this is the addition bit that I'm going to add. So how I add the addition bit? For example, I actually sum all this thing here. So when I sum it, if it's odd, okay, this addition bit, I will put a 1. When I actually do the sum on all this, okay, so you can see that this is even. So therefore, my addition bit is 0. Again, I do a sum on all this, and from there you know that this is actually even. So therefore, I add a 0 at the addition bit. So imagine this. If one of the bit actually go corrupted, for example, this actually go into 1. Okay, so when I actually do a sum, okay, it become a even. So therefore, I know that there is some issue on this message. So this is actually the role of the channel encoder. First thing, they add a simple addition bit. So the key idea when they actually add this addition bit is to counter any form of error. So from here, as I explained earlier on, if this bit instead of 0, they become a 1. So when I add all these 4 bits together, they are actually so-called even. So, but I see that this addition bit is actually a 1, which means that it's supposed to be an odd number. So therefore, I will be able to anticipate that there is actually some form of error over here. So basically, this is actually the role of channel encoder. They add one extra bit. The key thing is to combat against any noise, any interference. Okay, so basically is to ensure okay the message is received all in order in the receiver. Okay, so basically this is actually the role of channel encoder. Next, I come to the last one, which is the baseband filter. Okay, so in a digital transceiver, the baseband filter, in fact, will be a very critical component. They, in fact, act like a traffic cops. Okay, what does this mean? Okay, so basically, they take care of the signal bandwidth. They do not want people that so-called overlap onto other so-called signal bandwidth. Okay, so the primary role is to shape the transmitter signal and to filter the receiver signal to maximize data integrity and minimize interference. So in short, baseband filter is to filter the baseband signal to limit its bandwidth. Okay, without filtering, signal will have very wide frequency spectrum, much wider than is needed for the purpose of sending information. I just explain in a very simple word. Most of the data actually concentrate at the center. No point to so-called to transmit the whole signal bandwidth. So therefore, we actually truncate the so-called the bandwidth, and thereafter, when we actually can send that particular message, we will be able to recover the original message. And you can see from here, there are actually two forms based on the transmitter, based on the receiver. So for the transmitter, it's mainly to do some pulse shaping. Okay, so what they actually do is basically they limit the bandwidth and they actually eliminate away this ISI. Okay, as for receiver, okay, basically they are doing some form of match filtering and noise rejection. So the key thing is they actually maximize the signal to noise ratio and reject the out of band interference. Okay, so basically this is actually the role of baseband filter. based on transmitter, based on receiver, they actually has different role. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.